Jai Hind students, with this video, we begin with the first chapter of class 11th, Physical World. In this video, we will learn about what is science, which are various branches of science, what is physics, which are various branches of physics, and fundamental forces in nature. So let's begin. What is science? The entire material world around us, the air, water, earth, human beings, plants, animals, the sun, the planets, and the universe is called nature. Nature was not created by anyone. It always existed and will always exist. It varies or moves continuously. The planets and the stars are in motion. Rivers change their courses. Plants and animals grow and develop. Human beings also change nature continuously with their keen intelligence and labor. Over the centuries, mankind has constructed towns, settlements, works, and factories, plowed and sowed fields, invented various machines. As human knowledge of nature increased, we found that the changes occurring in nature are regular. That is, every phenomena has a cause. For instance, various objects fall to the earth because they are attracted by the earth's gravity. Day is followed by night since the earth rotates about its axis. Wind originates partly as the result of the non-uniform heating of the air. This organized, systematic, and formulated knowledge obtained through observations, experiments, and verifications is known as science. Science is further classified in three categories: broadly, physics, chemistry, and biology. Amongst these three categories, physics and chemistry is known as physical science. Physics is a science whose objective is to study the components of matter and their mutual interactions, and in terms of these interactions, explain the properties of matter in bulk, as also the other observed phenomena. Now, the physics is further divided into various branches. Physics is that branch of science which deals with nature and natural phenomena. In physics, attempts are made to measure the quantities with the best possible accuracy to explain the properties of matter. Therefore, physics can be also defined as the science of measurements or exact science. Though the subject of physics should be studied as a whole and as such be considered in a consistent and logical way, for the sake of convenience, it has commonly been divided into different fields of study, namely, mechanics. It deals with the motion of objects in macroscopic world. This branch is based on Newton's law of motion and law of gravitation. Thermodynamics. It deals with heat and temperature of large number of particles, which is called system. This branch of physics is concerned with the change in temperature, internal energy, etc. of a system through transfer of heat and the external work. Electrodynamics. It deals with the theory of electricity, magnetism, and electromagnetic waves. The basic laws of electrodynamics are given by Coulomb, Oersted, Ampere, Faraday, and Maxwell. Optics. In this, we study the nature and propagation of light, formation of images through lenses and mirrors, reflection, refraction, interference, diffraction, etc. The working of telescopes and microscopes are also discussed. Sound or acoustics deals with the nature and propagation of sound waves. Relativity. It deals with the theory of invariance in nature and the motion of objects moving with the speed comparable to speed of light. Nuclear physics. It deals with atomic nuclei and their properties. Particle physics. it deals with the ultimate particles of which matter is made up of. Quantum physics. It deals with the mechanical behavior of particles of sub-microscopic world. All the phenomena taking place in the universe are governed by only four forces, namely gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Gravitational force. It is the force of attraction between any two bodies or particles which has mass. Say we have two bodies, body A of mass m1 and body B of mass m2, and they are separated by a distance r. Then the gravitational force of attraction between the two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Or we can also write this as F equals to G m1 m2 upon r square, where G is universal gravitational constant. Electromagnetic force. The force that acts between the charged particles is called electric force, and that which exists between the magnetic poles is called magnetic force. These two forces are closely related to each other and as such are considered to be the two faces of the general electromagnetic force. This force is described in terms of exchange of photon. Now, the force of attraction or repulsion between two electric charge or charged bodies is known as electrostatic force. Say we have two charges, Q1 and Q2, separated by distance r. Then the force between the two charges is given by K times Q1 Q2 upon r square, where K is a proportionality constant. The other two forces, namely strong nuclear and the weak nuclear force, are: the strong nuclear force is the force which binds the nucleons in a nucleus together. As we know, the nucleus of an atom consists of protons and neutrons, both collectively known as nucleons. The force holding the nucleons inside a nucleus is known as strong nuclear force. Whereas the weak nuclear force is the force between the elementary particles emitted during radioactive decay of the radioactive substance. Now, let's understand the strong nuclear and the weak nuclear force in detail. In 1911, Rutherford discovered basic structure of atom, in which he found negatively charged cloud of electrons revolve around a positively charged nucleus. In 1917, he discovered proton, which is a positively charged particle held together inside the nucleus. As we know, like charges repel each other. Just imagine a simple nucleus consists of two protons. Since each proton has positive electric charge, they push each other apart. It's not a small force. They push each other apart by a force of 20 pounds. This force is so big that if you let two protons go away from each other, they would be moving away from each other with a speed of over 800,000 miles per second. Similarly, in bigger nucleus like uranium, total force protons are exerting on each other is 70 pounds. So, these protons are getting pushed apart from each other. Then what keeps them together? There is only one possibility, that there has to be a force which is stronger than electromagnetic force, which is keeping the protons together. This strong force is known as strong nuclear force. Nucleus of any atom consists of positively charged particles, protons, and neutrons. In a nucleus, we have number of protons and neutrons. Now, when this nucleus becomes unstable, the neutron decays and it emits electron and antineutrino. In this process, the neutron gets converted into proton. This process is known as minus beta decay. And the forces which are responsible for this minus beta decay are weak nuclear forces. Now let's compare the relative strength and range of forces. Amongst the four fundamental forces, the strong nuclear force is the strongest and the gravitational force is the weakest. The strong nuclear force is 10 to the power 38 times stronger than the gravitational force. The strong nuclear force and the weak nuclear force are short-range forces. That means they exist only in a very short range, that is, in a range of 10 to the power minus 15 meters and 10 to the power minus 18 meters respectively. Whereas electromagnetic force and gravitational force has an infinite range. So in principle, electromagnetic force and the gravitational force between any two charged particles or between the bodies can exist even at a distance of almost of a universe.